Okay, so we were talking about the effect of the radius on the rolling force and the roll radius, the rolling force, sorry, and the rolling torque. Okay, and we said that the torque is proportional to the radius. Okay, so it's proportional to R. So this is the torque equation. This is the torque function of R, while the force is a function of radical R. Okay, this is why the slope of variation of the torque is higher than the slope of variation of the force with radius. Now, concerning the power, what will be the effect of radius on power? We know that the power P is defined as the torque times the angular velocity. The total torque, yani 2t, for each roll I have t, 2t times omega. Now, if we replace t and omega by their values, so for the torque, okay, we have seen that the expression of the torque is, for each roll, it's 0.5 FL. So it's 2 times 0.5 times F times L. And omega is the roll velocity, linear velocity, over the radius. So now, if we 2 and 0.5 is 1, 2 times 0.5. Now, if we replace F by its value, F is Y flow stress average times the width of the plate times L times, yani already we have L in F, and times L another time, it's L squared, times VR over R. Now I will just replace L squared by its value. L squared is R times T0 minus T final. Okay, and then I have times, I will add here, times VR, okay, over R. So what will happen is that R will be simplified. This means what? This means that my power is constant for, if I only vary the radius and I fix all other parameters. Here I have same metal, so same Y average, same initial and final thickness, same width, same linear velocity. So I'm only varying the radius. Okay. So since I am only varying the radius and R is not affecting the power, then I can say that for variable radius, the power is constant. And what conclusion can I make here? If I can reach the same power with a smaller force and smaller torque, it's better. So when I use a smaller roll, I can achieve the same work because I have the same power, but with a lower force and torque. This is why this is the justification of configuration with small rolls. For example, the cluster type is using small rolls that are supported by big rolls. So because the small rolls have good effect since they can produce the same power but with a lower force and torque acting on them. And we put backup rolls that are of higher diameter in order to avoid bending. Okay. So here, this is the conclusion we can make, that for fixing all parameters, if we vary the radius, what will happen is that with increase of radius, the rolling force and rolling torque will increase, while the if you want, while the power will be the same. In actual case, the power might be, if you want, would probably increase because of lower mechanical efficiency in the cluster type. In cluster type, you have several rolls, you might have some losses, but the advantage is that you can produce the same power with a lower force and torque. Okay, so this is for problems on chapter 15. And do you have any question on this? So for next two sessions, I will post recorded PowerPoint on chapter 15 and videos. So it's nearly 2 hours. So you need 2 sessions to cover them. And hopefully on Wednesday we start with chapter 60. Okay. Thank you. Bye bye.